Hello everyone, good morning. This is Ramesh Kumar Singh, and in this video we will understand about the parallel combination. In my last video I have discussed with you about series combination, and due to some reason I could not complete the parallel combination. So here we will continue understanding the meaning of parallel combination, which is a topic of class 10th. So this video will be little bit lengthy for you because here I will explain you by writing by my own. So if you feel that this is going to be lengthy, so you can watch this video in by increasing its speed. You can increase 1.5 time, 1.5, and you can increase 1.75. Okay, so just increase its speed to understand it. If you don't have time, but if you have time, then please watch it properly to understand each and everything. So first of all, we will write its definition. What is the definition of parallel combination? So the definition of parallel combination is two or when two or more resistances, when two and more resistors, they are resistors are connected. How can they be connected? They can be connected between the same 2 points. They can be connected between the same 2 points. Okay, they are said to be connected in parallel combination. Okay, this is the definition of it. Now, first of all, to understand it, we need to draw a circuit of parallel circuit. So parallel circuit can be drawn like this. The three resistors, they can be drawn like this. This is the first resistor, and here this is the second resistor. Here this is the third resistor. They can be drawn parallelly. These are the three end points of the resistors. So these are the initial points of the resistors. Here we have to just draw it clearly because there is a little bit mistake. Yeah. So here you could have drawn it like this, and then you have to draw it straight. A second, let me draw it from the beginning. Okay, so we will draw it clearly in the next page. Just a second. Yeah, fine. So here in this page we will draw it. You have to draw first of all a battery, then you have to draw a key, then you have to draw an ammeter which has its sign plus and minus, and here you can just draw the three combination of resistors. Here also you can draw like this. Okay, so it has been started. Fine. This is going to be the first resistor, this is going to be the second resistor, and this is going to be the third resistor. Fine. So its name is R1, its name is R2, and its name is R3. And these points are called the initial joining points. These are initial joining points, and these are the three final joining points. Okay, these are the three final joining points. So you can name them. You can name them P, Q, R. Okay, and you can name it K, L, M, any kind of name you can take, and these are the these are the joining points with the series. So this point you can take it like X and Y. Fine. So I current is flowing in the entire circuit, and I current is flowing from negative to positive, and when it comes to this position, I current is also flowing here. But what happens is when I current comes here after X, it is like separated into three parts. First part is taken the I1 current, second part is taken as I2 current, and third part is taken as I3 current. Please remember, don't forget to just substitute the arrows. Make sure you have drawn the figure clearly by just showing your arrows properly. What do I mean by arrow? Like this arrow. Okay, so please make sure you are drawing the arrows clearly. Okay, so this was the entire diagram in which the current is like breaking into three parts. So we will understand its theory now. What we have done is you have to write first of all that let us consider let us consider three resistors. We have considered three resistors. Three resistors, they are joined in parallel. Joined in parallel. Fine. With a combination of cells. Inside the bracket you can write or a battery. Fine. Now you can write as shown in the figure. As shown in the figure. Now here total current total current I total current I is what? Is equals to what will be the sum of? It will be equal to the sum of the separate currents through each branch of the combination. Okay, so here what does it mean? That I was the total current. It is separated in three equal parts, which is I1 plus I2 plus I3. You can take this equation as equation 1. Okay, after this slide we will understand as to how to explain it furthermore. Okay, now let Rp, P is written in suffix. Rp, what is Rp? Rp be the equivalent. Rp be the equivalent resistance, or you can write resistor. Okay, Rp be the equivalent resistance of the parallel combination of resistors. Now according to Ohm's law, what is the Ohm's law? Ohm's law was that I equals to, sorry, V equals to IR. This was Ohm's law. So from Ohm's law, can we not write that I equals to V by R? Absolutely, we can write. So if we just write the Rp, I mean Rp, P is written in suffix. Okay, so here also you can write P. This was this can be written according to Ohm's law. Now, like using Ohm's law for uh, for these resistors, okay, for three resistors, we will get V by R1. So I1 will be equals to V by R1, I2 will be equals to V by R2, and okay, let me write it in the next slide. So what we have written, using Ohm's law, we can write for all the resistors that I1 equals to V by R1, I2 equals to V by R2, and I3 equals to V by R3. Now these are the values which we are going to substitute in equation 1. Now you can write substituting the values in equation 1. We will get what? The equation 1 we had I equals to I1 plus I2 plus I3. If you substitute these values, then I value can be substituted, that is V by R for parallel. I1 can be substituted, that is V by R1, plus I2 can be substituted, that is V by R2. Here you can write V by R3. Now in the next slide we will understand by taking V as common. Rp equals to V can be taken outside the bracket. So inside the bracket you have 1 by R1 plus 1 by R2 plus 1 by R3. So V and V both can be cancelled from both the sides. So 1 by Rp will be equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance. This is the expression, this is the formula for the equivalent resistance of parallel combination. Okay, so that was all, students. In the next class we will take another topic and we will complete them. So thank you so much for watching.